Today we're talking about Earth's invisible shield, the ozone layer. And, its story is pretty incredible. It's a tale about a silent, creeping crisis that genuinely threatened all life on this planet. And, maybe more importantly, how humanity actually came together and fixed it. All right, so to really get this, we first have to wrap our heads around a weird little paradox. It turns out the hero of our story, the ozone molecule, can also be a bit of a villain. It really just depends on where it is. So ozone basically has this double identity. Way, way up in the stratosphere, it's the good guy. It forms this amazing protective layer that blocks out something like 99% of the sun's most dangerous ultraviolet rays. But down here where we live in the troposphere, it's a totally different story. It's a nasty pollutant, a major ingredient in smog that's actually really bad for our health. So, same molecule, but its role is all about location, location, location. For a long time, we just assumed that shield, up there, would always protect us. But then, in the late 20th century, scientists started to notice something was going very, very wrong. Our shield was, well, it was failing. This process got a name, ozone depletion. And let's be super clear here. This wasn't some natural cycle. It was the direct result of specific chemicals we were making, which were literally shredding our protective layer faster than the Earth could naturally patch it up. So, what were these chemicals? Well, scientists started a kind of investigation, and they found the main culprits. They called them ozone-depleting substances, or ODS for short. And the most infamous ones were these things called chlorofluorocarbons, CFCs. I mean, they were in everything. Refrigerators, air conditioners, even hairspray cans. And the irony is, we used them because they were so stable and harmless, or so we thought. Okay, so here's how the crime went down. Because these CFCs were so stable, they didn't break down near the ground. They just floated up, 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 all the way into the stratosphere. And that's where the trouble started. The intense UV radiation up there, the very same radiation the ozone is supposed to protect us from, zaps the CFCs, breaking them apart and letting loose a chlorine atom. And this is the truly terrifying part. That one little chlorine atom acts like a chemical wrecking ball. It starts a chain reaction, just ripping apart one ozone molecule after another. We're talking one single atom destroying thousands of ozone molecules. That's why even a small amount of these chemicals in the atmosphere was a total catastrophe. And if you thought chlorine was the villain of the story, well, it gets worse. Scientists then found its chemical cousin, bromine. Bromine gets released from compounds like halons, the stuff in fire extinguishers. And it turns out bromine is like the supervillain. A single bromine atom can be up to 100 times more destructive to ozone than chlorine. Just unbelievable. Now, this chemical attack wasn't spread out evenly. Nope, it got dangerously focused over one place, the South Pole. This is how we got the infamous ozone hole. Let's head to the scene of the crime. It all kicks off with the totally unique conditions of the winter in Antarctica. I mean, for months on end, it's just complete darkness and bone-chilling cold. We're talking temperatures dropping to minus 90 degrees Celsius. Now, this insane cold creates something really special and, in this case, really bad: polar stratospheric clouds. These aren't your everyday fluffy clouds. They're made of tiny ice crystals, and they act as the perfect little platforms for all this destructive chemistry to happen. So you get this perfect storm. First, this powerful wind pattern, the polar vortex, swoops in and traps all the cold air and those nasty ODS right over Antarctica. Second, on the surface of those ice clouds, the harmless chlorine gets converted into a super reactive form. And then, when the sun finally peeks over the horizon in the spring, it's like a starting pistol. It unleashes this massive chlorine stockpile, which just tears through the ozone, creating the hole. So, a giant hole in our planet's shield, that's obviously a problem, right? It means way more of the sun's dangerous UVB radiation gets down to us. But what does that actually mean for life on Earth? Well, for us humans, the consequences were, frankly, terrifying. We're talking a direct line to a higher risk of skin cancers, higher rates of cataracts, which can cause blindness. It could even weaken our immune systems, making it harder to fight off all kinds of diseases. The stakes were incredibly high. And this wasn't just a human problem. The damage spread to everything. All that extra UV radiation was harming phytoplankton, these tiny little organisms that are the absolute foundation of the entire ocean food web. It was damaging crops, breaking down materials like plastics, and even making our air quality worse down here on the ground. The whole planet was in the line of fire. So, faced with this massive, undeniable threat to the entire planet, humanity did something kind of amazing. We actually got our act together. And what's really wild is how fast it all happened. In 1985, countries agreed to cooperate under something called the Vienna Convention. That was the start, but just 2 years later, they signed the Montreal Protocol, a landmark treaty that didn't just suggest action, it required a global phase-out of CFCs. It had real teeth. And you gotta understand, this wasn't just a handful of countries. We're talking about a near-unanimous global commitment. The Montreal Protocol is one of the most successful, most widely accepted treaties ever. It proved, without a doubt, that when we really want to, we can unite to solve a massive environmental crisis. And you know what? It worked. The ozone layer started to heal. But the story doesn't quite end there. It turns out that solving one huge problem accidentally created another one. So here's the plot twist. The chemicals invented to replace the bad old CFCs were called hydrofluorocarbons, or HFCs. Now, they were great for the ozone layer. They didn't damage it at all. Fantastic. The problem? They turned out to be super potent greenhouse gases, way more powerful than carbon dioxide when it comes to trapping heat. But here's the hopeful part. The world adapted again. In 2016, everyone came back to the table and created the Kigalea Agreement. It's an update to the Montreal Protocol designed specifically to get rid of these HFCs. And the potential payoff is huge. Getting rid of HFCs could prevent up to 0.5 degrees Celsius of global warming. That might not sound like much, but in climate terms, it's an absolutely massive deal. Which really brings us to this final thought. The story of the ozone layer is our ultimate proof of concept. It shows us that when science is clear about a threat and when nations decide to cooperate, we can solve planet-wide problems. Our shield is healing because we decided to heal it. So the real question it leaves us with is, what's the next great challenge we need to tackle together?